Okay, welcome back to our new unit. So in our first video yesterday in part 1, we talked about what similarity generally means, that we're looking for triangles or shapes in general that have the same ratio, right? We want it to be proportional. So today we want to talk about actual proportions. What are we talking about when we say proportional? What is proportion? How are we going to solve it? So hopefully this is a little bit of review for you. If not, pay close attention. Okay, so a proportion is an equation. It's just a certain kind of equation. Right? A proportion is an equation specifically that only has two ratios, one on each side of the equal sign. So you shouldn't see anything in a proportion other than a ratio on the left, a ratio on the right, an equal sign in the middle. If it's anything other than that, you don't have a proportion. Okay, so for example, you could think of it as ratio equals ratio, what you should see, or you could think of it as fraction equals fraction, right? If you see anything other than just two fractions equal to each other, it's not a proportion, and you can't deal with it in the way that we're going to talk about dealing with it now. Okay, I always think of them like this, and I'm going to, fractions are scary, but they're not nearly scary when you have smiley faces in them, right? So notice here, on the left, just a fraction, smiley face over heart. On the right, just a fraction, sun over cloud. Now, I don't care what these things are. They might just be numbers. There's going to be x's in here. There's going to be expressions like x plus 5 or 2x minus 7. And they can get more and more complicated, but the idea is going to be the same. I should have a fraction on the left and a fraction on the right. So when we talk about similarity, there's going to be a ratio that represents one triangle and a ratio that represents the other triangle. Okay. Now, when we solve proportions, like I said, they're just equations. But when we look at them, because it's all the fractions, it gets a little bit like, oh, what am I going to do? Okay, well, here's what we're going to do. The very first thing that we're going to do is use our friend cross multiplication. So some of you, depending on who you had for math, some teachers call this like the butterfly method, where they draw like these butterfly wings around the two things. But cross multiply just means this. You do a crisscross in your equation, and you multiply. You can be reminded that you're multiplying because you just drew a big fat multiplication sign. So we are doing crisscross multiplication. So you're going to notice something. When you do crisscross multiplication, one thing, first things first, your fraction disappears. Both of them disappear in one step. It's awesome. Okay? The other thing I want you to notice is that your numerators are going to stay put. Okay? So once we cross multiply this, I will have smiley face times cloud on one side, and then I will have heart times sun on the other side, because I'm crisscrossing multiplication. So this is just a quick rewrite. Right? So what I want you to notice is, again, smiley face and sun stayed put, right? The cloud popped up on the other side over here by smiley face. The heart popped up over here on the other side by sun. Okay, this isn't magic. It's just a quick rewrite. Right? It's an algebra rewrite. You could also do this in two steps by saying, you know what? I'm going to multiply on both sides by heart. Over here they would cancel. And then you could say, you know what? I'm going to multiply both sides by cloud. And over here they would cancel. You end up with cloud times smiley face and sun times heart. Okay. You can do it in two steps, but you don't need to. That's what cross multiplication is for. Now, again, let me be clear. If there's anything at all other than two fractions, you can't use cross multiplication, right? So if your equation looks like this, you can't use cross multiplication. Sorry, right? In other words, you can't just do this crisscross and then put a +1 over here. It's not going to work. Okay. Now, there's stuff we can do, but trust me when I tell you, you don't want to do it. Okay? It involves finding a common denominator, and you'll talk about that in Algebra 2 a little bit. For right now, if we see a proportion, it better just be fraction equals fraction. If there's anything else going on, that's not a proportion. Don't you dare try to use cross multiply. Okay, let's do a couple examples. All right, so at the top of the page here, I put our little cross multiplication theorem in case we need reminded, right? I'm just going to do a crisscross applesauce, as they say. Denominator from the right comes up on the left. Denominator from the left comes up on the right. All right, let's look at our first example. Okay, so Again, it looks a little less fun once there's numbers, but no big deal, right? I'm going to do a crisscross. Crisscross. So on one side, again, look, my 4 and my 2 are going to stay put. On this side, the X is going to crisscross and pop up here next to the 2. On the other side, this 7 is going to crisscross and pop up here next to the 4. Right? You have 4 times 7 when you cross this way, 2 times X when you cross this way. That gets me my cross multiplication. So over here I have 28, and over here I have 2x. Well, guess what? That's not a terrible equation to have to solve, is it, right? 2x equals 28. I just took a nasty looking equation that has 2 fractions in it, and in one step, we got it down to a one-step equation that we know how to solve. So once it's cross-multiplied, all we have to do is come in here and finish it off using DCMCS, right? So divide by 2 on both sides. 28 divided by 2 is 14. Okay? It's like a really nice, straightforward proportion problem. So I have a single fraction on the left, a single fraction on the right. Do a crisscross. Okay, this one is for you, number 12. Let me move my floating head. Okay, this one is for you. Try this one. Okay, let's get it going here. I need to do a criss and a cross. Whoa, don't look at that. A criss and a cross, right? So again, ignoring your denominators, the top part of your equation is going to stay the same. I'm going to have a 19 and an x, right? I just need to bring my denominators up, and I bring them up and across. So the 10 is going to cross up and join the x. The 12 is going to crisscross up and join the 19. Okay, so I have 19 times 12 on one of my sides and 10 times x on the other side. So again, one quick step, and I took an equation that has 2 fractions in it and both fractions gone. All right, let's cheat a little bit. 12 times 19 is 228. X times 10 is 10x, right? Not too exciting. I like to rewrite them like this because I like to have my variable on the left. That's just me. That's just who I am as a person. Looks better to me. Okay, so to solve this out, to finish this, it's only a one-step equation. All we have to do is divide by 10 on both sides. So if you got a fraction when you were doing this and you said, oh, geez, I think I'm wrong, I got a fraction, pat yourself on the back. You didn't get it wrong. Fractions are numbers too. Okay, now the next two, they have a little layer added, right? There's still fraction equals fraction. But what I want you to notice is here in number 13, the fraction got a little spicy, right? So instead of just having an x up here, it's an x minus 1. Okay? And we're going to do the same exact thing. There's just one thing we have to remember. When you cross multiply and you bring, let's write it out, my x minus 1 is going to stay, my 13 is going to stay. My 6 is going to crisscross up and multiply my 6, or multiply my 13, right? This 19 is going to cross up, and it's going to multiply by x minus 1. But here's the trick. It's multiplying by the entire x minus 1. So in order to make that happen, I can't just write times 19 here. Because if I do that, I'm only multiplying the 19 by the x, and I'm ignoring the 1. Order of operations would tell us here to do the multiplication, and then I can't do that. So when I say, okay, well, let me multiply my 19 up to this x minus 1, you have to put your x minus 1 in parentheses. That is a huge deal. It's probably one of those common mistakes people make when they're solving proportions. One of the things you can do, if you find yourself, if you're not sure, put it in parentheses. It can't hurt. If you put up here, if you said, you know what, I'm not sure if I'm supposed to have that 4 in parentheses. Who cares? Put it in parentheses. It's still 4 times 7, right? Down here, if you're not sure, put the parentheses around it. That you literally can't go wrong with the parentheses, right? But the parentheses tell us something. We did DCMCS. We know what you have to do here. The D in DCMCS stands for distribute. I've got parentheses here. The first thing I have to do is distribute. So in order to solve this equation, I need to distribute. So I'm going to get 19x minus 19. If you didn't have the parentheses there, you would just have 19x minus 1. That's not right. On the other side, I just have to multiply 13 times 6. So let me do that. 13 times 6. 78. Got smart today. I got my calculator, so I don't have to try to do all that arithmetic. Okay, so I'm going to recopy this up here. 19x minus. What if I told you that my computer stopped recording and I was sitting here not only talking to myself, but it wasn't even recording for the last like 15 minutes? That's fine. Let's just pick back up where I left off here with recording. Okay, I was recopying this 19x minus 19 and celebrating the fact that I remembered my calculator. I think that's where I left off. Okay, so I got to do some DCMCS here, right? So I'm going to leave this x because he's where I like him. He's on the left-hand side. So let's add 19 to both sides. When you do that, cancels on this side. I've got 19x, and over here, 78 plus 19 is 97. I don't know that off the top of my head. I just did the calculation. Okay. Last but not least, all we have to do is divide through by that 19 and call it a day. Now this fraction, you get just a yucky decimal, right? So when I do 97 divided by 19, I get a long decimal. I get 5.10526, blah, a bunch of other stuff. Okay, so you can write the decimal to a couple decimal places, or you can just leave it as 97 over 19. That's fine too. Okay, but again, I need to point out, and you're going to do this number 14 here in a moment, that when you're working on these problems, as soon as you see something in this numerator or the denominator, it doesn't matter where it is, that is a quantity, that is something other than just an x or just a number, where it's things being added or subtracted, like you do over here in number 14. See this? Alert, alert. Okay. You're going to need some parentheses, right? So you might decide, and it's a really good habit to get into, that as soon as you see something like that, as soon as you see a plus sign, just go in there and just write the dang parentheses right into the problem. Okay, that will help you not forget. Okay, take a moment, try number 14. We'll talk about it. Okay, here we go. Ready? I am going to recopy my equation without the denominators, right? I like to start this way. So I have 5 on this side, and I have 19 on this side. Okay, let's see what's happening here. This 17 has to crisscross up and multiply by 19. This x minus 4 has to crisscross up and multiply by 5, right? And it's in parentheses. Because if it wasn't, trouble. Now that I have that, all I have to do is use my DCMCS to solve this thing. Let's see. Let's do 19 times 17 right now just to get it over with. 323. 323. Okay, so I have 5 times x plus 4 parentheses equals 323. So let's distribute, shall we? 5 times x is 5x. 5 times 4 is 20, so I just do my plus 20, and 323 on the other side. DCMCS is bringing it home, right? Distribution, done. I'm going to leave the 5x. He's where he belongs. He's on the left. I'm going to move this 20. That leaves me with 5x on one side and 303 on the other side. Can't you just smell the decimal creeping up on us? I can hear him coming around the bend. Right? I'm going to divide by 5 on both sides to finish this thing off. And if you want to leave it as 303 over 5, that's fine. If you don't, you can divide it out. 303 divided by 5 is 60.6. It's not as ugly as a decimal as you might think, right? But it's fine, again, to leave it as a decimal, or it's fine to write it as a fraction, right? Whichever one makes you feel better. Okay, so what I would like you to do now is head over to Desmos and work on the proportion activity so that you can get some practice, refresher on doing proportions before we take proportions and add the similarity layer to it, because we're talking about them for a reason, right? We're going to use these when we talk about similar triangles. Okay, so head over to Desmos, and we will see you soon.